So let's talk about simple interest. First question we should have, what is it? What is simple interest? What makes it simple? What's interest? So let's just say, for example, you're going to the bank and you have, say, $300 in your back pocket, right? You want to invest this money. So when I say invest this money, I mean that you're going to give it to the bank and they're going to take that money and they're going to say, well, in a year, we're going to give you, let's say, 10% interest because it makes the math real easy. So what that means is we take 10% of what you gave us, then we'll add that on to your total, right? So you have your original $300 plus an additional 10% on top of that. So you grow your money, right? So you now have $330 because you added the 10%, the $30, right? And then just keep going like that every year. So the next year you'll have your base 300, then you'll have the extra 10% on top of that, and then another 10% on top of that, so another $30, right? Giving you a total of $360. Right? And simple interest just keeps going up like that by the same amount every time, right? So each and every year you go up by just another block. In this example of $30, right? 30, 30, 30, giving us $390. Okay, so just like that. That's simple interest. Just going up by the same amount every time. So that's all well and good. How do we use it? How do we calculate things with it? Well, let's take a look at some examples and I can show you the formula. So let's take a look at this example. So let's say we have an investment with an 8-year term on a principal of $30,000 at 3.5%. So that's a bunch of information that we don't know how to deal with yet. So we get a look at the formula. Okay, so the formula that we use for simple interest investments is the future value, I'll talk about these in a second, equals the present value, times 1 plus the rate times the term. Okay, so that's our future value. I'm just going to write these in. What that means is what the value of the investment will be in the future. Okay, so like looking at our example back here, this might be the future value if that's the end of the terms that you're using. Okay, and we have the present value, or the principal. Right, it's also called the principal, it's just the money that you start with. So back in this example, that's the $300. Okay, 1 is 1, R is rate, as a decimal, and T is the term. Okay, so it's basically the number of times that you earn interest. So in this case, we have an 8-year term with a principal of $30,000 at 3.5%. So we can say the future value, we're going to find the future value here, equals the present value, which is $30,000, right, because that's our principal, times 1 plus, and of course when I do a bracket like this, that means times, 1 plus R times T. Now R is 3.5. We can't use 3.5 directly, right? 3.5%, can't use it. But if we were to divide it by 100 to get to a decimal, we can use that. So 0.035 times the term of 8 years. Okay, so now we just do some simple math here. So we've got some FV equals 30,000. I'm not going to touch this just yet. Let's just do the interior here. So if we take this this back end here, so 0.035 times 8, that'll give us 0.28, right, 0.28. And we want to add the 1. So if we add the 1 to the 0.28, we get 1.28. Okay, And then all we have to do is we have to multiply these together. So we rewrite it. So we get FV equals, and then we have 1.28 times 30,000, which will give us 38,400. Okay, so that means that if you invested $30,000 at a rate of 3.5% and left it for 8 years, you would have $38,400. Simple as pie once we get here. Okay, so that's how we solve for future value if we have all of the other information. Okay, what if we wanted to do that a little bit backwards? What if I knew how much money I needed? Like if I was saving for something, and I knew how much money I had, but I had to find an investment that had a particular rate to meet that goal in a certain amount of time. So let's take a look at an example like that. Okay, so flipping it around, we've got Cam here who has $5,000 to invest. He wants his principal to grow to $6,500 in 5 years so he can afford a new drum kit, right? So setting goals, finding out what you need to save for. What is the simple interest rate that will allow him to meet his goal? Okay, so we have just one formula that we're using right now. Future value equals the present value times 1 plus the rate and the term. Now our issue comes up immediately. We have the present value. We have the future value. We have the term. We don't have the rate. We don't know the rate. We have to solve for the rate, but right now this is not set up to solve for the rate. But that's okay. We can just start sticking stuff in, start solving it a little bit, and then we can make our way to the end here. Okay, so let's just start by sticking in all the numbers here. We don't need to stick in the numbers. You could solve this symbolically first, but I know most of my students prefer that I do it with numbers, so I'll do it that way. Okay, so the future value is what we want the money to end up as. So in that case, it's $6,500 since that's what he's saving for. And that'll equal the present value of $5,000. That's how much money he has right now. Okay, then we have 1 plus the rate, which is R, we don't know it, and the term, which is 5 years. Or rather, just 5 will be fine. Because there's 5 periods in which the interest accumulates. Okay, so let's start by solving this here. So we got 6,500 on this side, not much to do about that just yet. Okay, but we want to get rid of this 5,000. Since we start as far away from the R as possible, we want to get rid of that 5,000. We have a times 5,000, so we want to do the opposite here to get rid of it. So we do a divide by 5,000. Okay, so we're going to divide this whole side by 5,000. And because math is fair, we do the same over here. Okay, give myself some extra room there. Okay, 5,000 and 5,000 cancel. They make 1, so we don't care about them. Then we have 6,500 on top of this fraction here, divided by 5,000. Okay, that should give us, we'll rewrite it down here, 1.3 equals 1 plus R times 5. We're going to put 5R, just because it's easier for me to write. Okay, so again, we're just going to get rid of things that are as far away from the R as possible, so that's the 1 over here. So here we have a plus 1. To get rid of it, we have to do the opposite, which is minus 1. And we do that to both sides. So that will give us 0.3 on the left equals 5R. And finally, we need to get rid of that 5. We have times 5, so we do the opposite. We divide by 5 to get rid of the 5, dividing by 5 on the other side as well, which will give us 0.3 divided by 5, which will give us 0. Whoops, make that a black number here. 0.06 equals R. Okay, so that's almost our answer. Right now we have it just as a decimal. We want the interest rate, which is generally expressed as a percent. Okay, so if we take our decimal 0.06 and multiply it by 100%, we will get it as a percent. 6% is our answer there. Okay, so we'd have to find an investment at 6% to earn that money in that amount of time. Okay, so we've looked at finding the future value. we've looked at finding the rate, and this kind of method, solving it with algebra, could be used to find the term or the present value if you're given all of the other pieces of the formula here. Could find any of them there. Okay. So let's take a look just at one more example here of a different concept that we often use when we're talking about simple interest. Okay, so this last concept we call the rate of return. Okay, so the rate of return is just a percent that represents the net gain or loss in an investment over a specified period of time. Okay, so what it really means is how much did you gain or lose? These are often used in cases where you don't have a specific set rate, right? So it would be looking back on an investment that has had the rate go up and down. So you can kind of look at the investment and say, you know what, that one wasn't great, I lost money. So you can reinvest. But we'll just use it with simple interest today just to practice it. So the rate of return equals, rather, the current value. Okay, so it's the value of your investment currently when you're looking at this, minus the original value. Oops. Over the original value. Okay, so I use those terms because this isn't necessarily going to be the future value or the present value. It is the value of when you were looking at it versus when you started. But for the purposes of simple interest, it will be the current value is your future value minus the present value over the present value. Okay, and then times 100%, just to go from a decimal to a percent. Okay, so let's look at a quick example here. Won't take more than a minute. Okay, so question we have here. A principal of $1,000 is invested at 5% simple interest paid annually for 5 years. What is the rate of return? So first, we need to find, since we have the present value, we need to find the future value. So let's do that real quick. We've got the future value equals the present value, more practice, times 1 plus rather, the rate times the term. Okay. Final value equals the 1,000, not 3,000. $1,000 times 1 plus the rate times the term. The rate is 0.05, but we convert that 5% into a decimal, and the term is 5 years. Okay, we put all that together and we get the future value equals 1,000 times 1.25, and then finally we just multiply all that together. We get final value equals $1,250. Okay, that went a little bit quickly, but that's because I already did an example a little bit earlier about this. So this is just the same stuff. Okay, so now we do our rate of return. So rate of return equals the final value minus the present value over the present value. So our rate of return equals the final value, which is 1,250 minus 1,000 over 1,000. Okay, so we get 250 over 1,000 until our rate of return equals 0.25. Multiply that by 100% to get our percent. We get a 25% rate of return. Okay, so that's how much the money increased by, is 25%. Okay, so that is our simple interest finding the future value, simple interest finding other values using algebra, and the rate of return of an investment over a specified period of time.